Good morning, everyone. Well, we are going to start with this webinar. Good morning. My name is Adrian. I will be moderating this event today. We are FINOA Foundation, based in a European foundation that works for the innovation European funds. We are based in Brussels. And this project today is it's organized by the Life Eco Digestion 2.0 project that our coordinator Carlos Lafita will explain what it's about in a few minutes. But first, we are going to also to discuss innovative solution for water resilience and sustainability in Europe. We will have several best cases of different life projects, and we will have a discussion to find synergies and networking among different life projects. But first of all, let's welcome the distinguished speaker, Joaquim de Eugenio. He is policy advisor for zero pollution at the DG Environment from the European Commission. So welcome, Joaquim. You could start your presentation. Thank you.
Hello, good morning, everybody. Good morning to you and to all the participants. I'm also based in Brussels at the moment. I'm in the venue of the European Green Week conference, which is just a few meters away, and I'm very happy that I could leave the conference a little bit and join you, because I'm very excited to speak to you, because what you're doing with the projects, particularly with the EcoDigest project, but also the other projects, is right of what is needed now to move the EU towards EU water resilience. And so I'm really excited that I'm able to give you a little bit of feedback from the policy side, and obviously hopefully help that the meeting that you're conducting now is able to feed into this policy process. So I was a bit confused just now because a pop-up window came up to ask me which language I'm speaking. So I hope it's okay that I'm speaking in English to you. I will share my slides, and I will probably go very quickly through the slides, some of them, to focus a little bit on areas which I think are probably most of your interest. But I have also told the organizers that they're more than welcome to share these slides with all of you after the meeting. So when we look at the last couple of years and the way the European Union and the European Commission has driven its Green Deal and its environment policies, it was very much linked to the triple planetary crisis. So climate change, biodiversity loss, and pollution, we all know are key planetary challenges that we need to address. They're all interlinked, but if you look at them, they are very closely intertwined with the water crisis. So water is a big part of all of them. And that's why we really try to develop a policy framework that is very much integrated and stretches over the variety of aspects. So we have in the Green Deal already looked at very many cross-cutting issues from water, whether it's linked to drinking water, agriculture, energy consumption, and that's where also looking at wastewater comes, of course, into the picture. And so we have on one hand addressed the specific triple planetary crisis with a number of proposals, but also looked at the sectors that need to transform. So the energy sector, the interlinkage between the environmental agenda and the energy agenda was extremely important during this mandate, as you will imagine, with the energy crisis taking place. And looking for new solutions on how we can become climate neutral and energy efficient at the same time. And for that also, we're looking very much at the enablers. And of course, one of the key enablers is research and innovation. We've done a lot. This is very briefly to say is that after 4.5 years on working on the Green Deal, we have really changed the agenda in such a way that that we are transforming the economy, the society, on the basis of addressing climate change, on the basis of addressing environmental degradation. And as part of that process in the field that we are overlooking, more than 50 legal acts have actually been proposed, and most of them are agreed now in this mandate. So we are very much now looking on the next step of this work, because the work has only just started, because we want to see these green opportunities as opportunities also that drive and deliver for our economy and for our people. 4 proposals that I want to zoom in. I will actually zoom in only in 2, because in the interest of time, I won't go into too much detail, but I have 4 proposals that we put forward that are specifically linked to water. It was the work on implementing the Drinking Water Directive, a revised wastewater treatment directive, some more specification of what pollutants should be addressed in water policy. Last but not least, a revised industrial emissions directive. And now looking at the Urban Wastewater Treatment Directive, you will see here with one slide the key elements that we brought in. This directive was more than 30 years old. It was in need of modernization. It was in need to addressing a number of issues. And we have worked on one hand on the classical water protection, water treatment aspects. We have looked at how to deal with individual treatments, how to better improve nutrient removal from micropollutants, which includes also microplastics. All of that we looked very much in such a way that we introduced a more integrated approach, and we introduced also a more risk-based approach to addressing water quality aspects. But what is completely new, and what is, I think, really also groundbreaking, is the aspect of linking the wastewater treatment services with the need to achieve energy neutrality, with the need to contribute to reducing greenhouse gas emissions. And there we have, for the first time, introduced a systematic monitoring. We have introduced an ambition that by 2040 this energy neutrality shall be met. And we also introduced a number of other incentives to reuse, for instance, some of the resources that feeds into the circular economy, which then, for instance, also reduces secondary greenhouse gas emissions by not having to mine, for instance, new resources for phosphorus, for example. And last but not least, there's a lot of governance aspects that we have looked into. I think the most prominent one, I would say, are the introduction of an extended producer responsibility, where we share some of the burden of costs for introducing additional treatment with those polluters or those industries that produce certain pollutants that have to be removed by advanced treatment. And we've introduced also provisions to do monitoring of health-related parameters, which is a result also of the positive experience that we had during COVID, where this was a very good means to follow, to anticipate some of the pandemic-related issues through the monitoring in wastewater. Equally important, I think, and probably also interesting for you, is to know that we have also with the revised Industrial Emissions Directive introduced new elements. As you probably will know, the directive looks at all emissions and all environmental impact of more than 45 sectors, industrial sectors. And so water treatment, wastewater treatment is an integral part there as well. And the same philosophy as we've applied for the urban wastewater treatment plants, also here we want to make sure that the new Industrial Emissions Directive contributes to energy efficiency, reduces greenhouse gas emissions, and I think that is very important, is a driver for innovation, which is why we have created with this directive a new innovation center for industrial transformation and emissions, which will soon be launched in Seville by our joint research center. This directive is already adopted, finalized. The wastewater directive is just in its final stages. There are some formalities still to be done, but it is agreed already. So these directives have now been come to the stage where we move from the policy design to implementation. And I'll say something about that in a minute. In the interest of time, I will skip to that already. We have identified that, of course, the water crisis is one that we will need to focus next. That is why we have the Green Week on water resilience. And that is why we have launched yesterday a new communication campaign, which tries to see water differently with 3 objectives in mind. We want to restore and protect the broken water cycle. We want to build a water smart EU economy, and want to ensure clean and affordable water and sanitation for all. And in that respect, I mean, it becomes very important that we change the way in which we design our water services, drinking water, wastewater, to fulfill the overarching societal objectives. And innovation is a key part of this zero pollution water resilience agenda. We have already a lot of people, 1 million people, that are employed in the sector, and it's, from our point of view, a growth sector in terms of employment, and it has benefited through the various crises that we have gone through in a very positive way to stabilize the economy, because these sectors normally are the water sector is normally one that is more resilient towards such crisis shocks than other sectors. In that respect, I want to underline that innovation is very important when it comes to pollution prevention, and that goes both for greenhouse gas emissions and for other types of pollution, because often we are trying to remediate the problem. And I think some of the ideas, and I think there where you are also looking into with your research, is really to try to prevent some of these issues before they're actually becoming something that needs to be fixed at the end of pipe. And last but not least, before I close, digitization is a key issue that we are promoting in all our activities, whether it's on zero pollution, water, resilience. I think there's the age of the digital and green transition is now at a stage where we can really make a big jump in terms of what is possible, what was not possible before. But in order to achieve that, we believe that skills in the green and digital transitions are our foundation to make that happen. So to conclude, and I think that's where I think you are very perfectly timed with your project, because I think you're very much feeding into that. We have set the policy design, the policy stage, the legislation is in place, and we now just have to start acting on the basis of these objectives and on the basis of these provisions, these agreements that have been reached. So implementation on the ground is the key. We need innovative solutions, we need concrete solutions, and we need something that works, that is affordable, and that can be rolled out not only in 1 or 2 places, but can be rolled out throughout the sector and throughout Europe and throughout the world, maybe. So your project, other projects that are trying to now to look for concrete examples to fit into the new ambition of climate neutrality, avoiding biodiversity loss, reducing pollution, and achieving water resilience is perfect. I applaud you. I will try to listen as much as I can to the other presentations in between the other meetings, but I also know that my colleagues in SENEA are regularly feeding us with the latest interesting results from all the live projects. And I'm very much looking forward to hearing your news and your results, and wish you a very successful seminar today. Thank you very much.
Okay, thank you, Joaquin, for your contribution. I think has been very interesting for all the participants today. In fact, we are celebrating this year the 32nd anniversary of the LIFE program, and in fact, the LIFE program has been one important program supporting the innovation in zero pollution. I don't know if you have experience with other LIFE projects or I wanted to ask you, what is your opinion? How can the LIFE program support or keep supporting innovation for contributing to the objectives of the zero pollution?
Yes, thank you. No, I know the LIFE program. I've been working now for nearly 25 years in the European Commission, and I was in the first years already involved in the LIFE program by analyzing some of the proposals and so on and so forth. So I'm a big fan of the LIFE projects. I'm a big, let's say, contributor in that sense, is because a lot of the time when we look at concrete examples, etc., the first thing we do is we look into the LIFE database and see what has been done already and so on and so forth. The LIFE program is, compared to other programs, if you compare it, for instance, to Horizon, a relatively small program, but it has over and over been demonstrated that it's a very effective program, and it does exactly what you're trying to do is, so at the right time, come with concrete solutions that work in practice. So things that are not just for the laboratory, that are not just from a theoretical perspective, nice ideas, but things that can be rolled out across countries, across the EU, and maybe even beyond. And that is why such meetings like the one that you're organizing today is essential, to share these practices, to already share some early results, even if the projects are not finished, and to make sure that you always keep this focus on the policy needs. And as I said, now the time is to show that we can run our wastewater treatment plants without producing any or a minimal amount of greenhouse gas emissions, and making them circular and making them as zero polluting as possible. So if we manage to do this little by little, then we can really change the way in which little by little investments are directed into renovating or building new wastewater treatment plants.
Thank you very much. It has been a pleasure to have you here in this event, and you have time, even if you are in the Green Week physically, to have time to be here with us online. Thank you very much.
The pleasure is all mine. Good luck for the meeting.
Thank you. Now, it was expected to Juan Manuel to present the European funding opportunities such LIFE program, but he won't be able to join. So I will explain myself the LIFE program. Okay, I'm going to share the screen, and I will tell you, all of you, before we start with the concrete examples and the other LIFE projects, we will explain what is the LIFE program, what is a LIFE project, which are the programs. I will be very brief. So if in the future anyone have any doubt, of course they could contact us, and we will explain more in more detail. Well, as we were telling before, LIFE program it's now celebrating the 32 anniversary. So it has been 32 years since its creation in 92. It's been supporting thousands of projects in Europe. So we've been, well, it's a very successful program because it's keeping going on during 32 years. So it's supposed it's a very successful program. It is divided in different sub-programs. Okay, now we are going to explain a little bit what are the sub-programs very briefly, and what type of projects you could apply for. We have the sub-program Nature and Biodiversity. It's to protect species, for example, some endangered species, some to fight against alien introduced species, biodiversity, so on. Okay, now it's not our focus today. Our focus is more in the circular economy projects, like all the water and waste and the production of biogas projects, like today we're going to see the colleagues. And also we have another sub-program for climate change mitigation and climate change adaptation. It's also everything related to production of energy, sustainable energy, so on. And in the last years has been a new sub-program recently created. It is the transition to clean energy. It was an Horizon. It was within the Horizon framework, and it was moved to LIFE program. So within these different sub-programs, we have different type of projects. Okay, we have the traditional projects, the standard projects, as they call it. Before they call it traditional, now they call it standard. It's the usual projects that we are going to know today, to meet today. Okay, then there are specific kind of projects that we are not going to explain today. We are not going to know deep in today because we don't have enough time. There are strategic projects focused on regions, in different regions, to implement strategies and plans. We have technical assistance projects to prepare strategic projects. And then we have also a specific line for NGOs in the LIFE program. Also, just to mention that Clean Energy Transition Program, it's quite different from the standard projects because it has a different amount of co-financing and different type of project. Well, each sub-program has a different budget, so if you are going to apply, you should know that you have, in total, until 2027, we have more than 5 billion in English, 5 billion euros for all the program. And this year there is around 500,000 millions for all the sub-programs. The difference in each type of project, it's the co-financing. Okay, you have 60%. It's the usual 60% of all the costs that you have in the project is the usual. But depending of the type of actions, for example, nature and biodiversity could reach 75%, or the clean energy transitions, it goes until 95%. Okay, as I will go very, very fast in these slides. Nature and biodiversity subprogram, it focuses on protecting species and ecosystems. Then what is more interesting today is the circular economy and quality of life. It's focusing not only in circular economy. This program is called circular economy, but previously it was not an environmental, like it includes everything related to the environment. It includes circular economy, but also noise, air pollution, chemicals, everything related to waste, soil, urban environment. With the new Bauhaus, it is included also in the circular economy support. Okay, climate change mitigation adaptation. It's similar to circular economy, but it has different objectives, different type of projects. If you have an idea, the first thing you need to do is to check which subprogram you are going to apply. The transition to clean energy, it's more focused on governance, let's say. It's projects that wants to apply some politics, some strategies in different countries. It usually requires 3 different countries, like Horizon does. Not traditional life doesn't require an international consortium. It could only be a national, regional, or even local consortium. It is recommended, but not. It's not obligated. You are not obligated to have an international consortium. But in the clean energy transition program, you have to have 3 partners at least from 3 countries. Well, what's important here is the requirements for a LIFE project. Of course, there is no required a consortium. You could apply alone, but it's not common to apply alone in this type of projects. You require some type of consortium to collaborate in finding the common objectives. So it usually recommended 3 to 5 partners at least. It could be more, it could be only 2, but 3, 5, let's say it's the average. Projects, they range from 500,000 to 3 to even to 10 millions. It could reach to 10 millions, but it's not common, and you need to justify a lot that amount of money. Usually the projects go around 1, 2, 3 millions. Usually the average is from 1 to 3 million. Okay. As I was telling you before, the funding is 60%, but it could reach 75 or 95%. And also the size of the project, it's usually from 3 to 5 years, usually. Okay, there are projects we are now a part of a project with 7 years because it has to study the impact of climate change in a coast. So it requires more years to analyze the results. But usually the LIFE projects, 3, 4, 5 years, it's the average. It is open to every type of partners, public entities, SMEs, large companies, universities. You need to be, of course, legally registered. And also, of course, they will evaluate the consortium, so you need to show your experience or your capacity. Okay, it's open to all Europe and some some European partners. Usually, recently last year, it was included Ukraine as a totally eligible partner. And well, you could check there, see if there are new third countries who are eligible. Depending of the program, there are more or less countries. Usually in life, only Europe and some specific countries that are eligible. Well, the consortium in this type of projects should be, it needs a coordinator with capacity and experience. For example, now Carlos Lafita will explain Life Ecodigestion, that Global Omnium themselves are coordinating this project. They have experience, they have the capacity. So yeah, you need to be, the coordinator should be should have enough capacity, as you need to receive the funding, divide between the partners. So when you are applying for a project, look for a coordinator with experience at least. It is recommended a public-private partnership, so maybe a public entity, an NGO, or a non-profit foundation. You could include an SME, some multidisciplinary consortium. It will be positive as well. Okay, you have here some links for a partner set. If you are preparing a project in the next call, you could check here the partners. Okay, this is open every year, once a year only. So you have only one opportunity per year. Now in 2024, you have until September 19 or 17 of September for most of the programs and type of projects. So you have 4 months left if any of you are interested. 4 months, or you'll have to wait until September of next year. Usually, every year is in September. Usually, okay. We will share you the slides so you could check all the details later. Well, you will get an evaluation. Yeah, it could be evaluated by external experts, so you should know that it will be. So it's difficult, it's competitive, the evaluation will be hard, so you need to have a good proposal. Just, well, to mention the award criteria, you have to explain everything from the innovation that you are proposing in this project, the quality of your proposal, the budget. It's very important that the budget goes according to the activities that you are proposing and to the impact that you have. It's not the same if they give you 3 million for a project with no impact, or with small impact, 3 million euros, and you will solve a lot of problems. So depending of the impact that your project will have, they will be able to offer you the amount that you are requesting or not. So it's quite important. Well, it is open a call for external evaluators, and I was saying, so if any of you are interested in become an evaluator of life program, I think it's well paid. So you need to be quite expert in some thematics. For example, if you are very expert in the biogas production because you are the CEO of a very innovative company and you want to be evaluator, or you are professor in a university and you want to become an evaluator, well, you could apply and they will check your CV and they call for experts. Well, you need to submit a proposal with 120 pages maximum. Okay, we have the first section with administrative data, and then the part B with the technical description up to 120 pages. You have then a budget table with all the budget. And of course, you need to include staff costs, you need to include subcontracting, you need to include all the travel that you have to do with the project, and everything will be submitted and evaluated. Well, I'm not going to explain a lot more because we don't have enough time, and we need to go to the important today, that it's the projects that we want to hear about. We want to know about the Life Ecodigestion project, that is the what we are here today, and to hear about the other projects and to find how can we find synergies among them. So I go directly to Carlos Lafita, who is going to explain us the Life Ecodigestion 2.0, which is the following of Life Ecodigestion, so without number 1.0. Okay, so it's the second project that they are carrying out. Okay, welcome, Carlos.
Thank you very much, Adrian, for your presentation. I'm going to share my screen, I think like this. I think you are able to see my screen. I'm going to do in presentation mode. Do you see my screen? Yes? Okay, perfect. So let's start with the presentation of the project, the Life Ecodigestion 2.0. This is a project that is working in this digitalization and digital control and decision in water sector. It's our contribution to this item that has talked Joaquin before. This is important because we need to improve the way we treat water and also sludge we produce in waste treatment plants. And also we had to face two new challenges that there is in water sector, like energy demand and also other challenges that is not focused in this project that is our emerging pollutants, for example. Well, these are some numbers of the project. The project is called Innovative Technology Scale 4 Scale for the control and automation of co-digestion waste treatment plants to produce green energy on demand. This is, as Adrian said, this is the continuation of other previous project, also Life project. In that project, we work in the development of a tool that worked only in local, in a pilot plant, and now the idea is to scale up this tool to work in real scale plants. So the idea is to go to this new scale, and also the previous project we only worked in food waste as co-substrate, because the idea is to control the co-substrates addition in wastewater treatment plants digesters. In the digesters, we usually treat or stabilize sludge we produce during the process of water treatment. And then the idea is to increase the energy we can produce with these co-substrates. These at least are wasted that they produce in the industrial sector. And then to have this energy, but on demand, just to avoid the excess of production or the lack of production. And the idea is not only to work with food waste as we work in the previous Life project, also to work with pig manure. That is a challenge also for anaerobic digestion, because they have some drawbacks like its content or high content of ammonia in this. That at least is is an inhibitor of the digestion, anaerobic digestion. As Adrian said, usually in Life project we have from 3 to 5 partners. In this case, we are 3 of us. Agua Centro Litoral is our partner in Portugal. Finnova is the organizer of this webinar. And Global Union, that is the company I'm working and is the coordinator. The project is now 5 years long, because we need 1 year extra because we have some issues in the project, and the budget of the project is about 1 million euros, and funding is about 55% of this 1 million euros. The objectives of the project basically is the main objective is to produce or to increase the production of biogas in our facilities. At the end, not only biogas, the important thing is to increase also the production of methane. That this is the energy gas we can burn and produce energy. And also to increase the capacity of our facilities to do the co-digestion, to treat waste in our facilities. Both of them, as told you before, food waste and also pig manure. Well, how we can do this? The first thing we're working on is the improvement or the upgrading of the current digital solution we have from the previous project. The first idea is to migrate this local work of this tool to web work. in a server. That is, means that we are not working or we need to work online. That have some challenges that we try to face during this project. Also, the idea to do this is to have a most robust and scalable software, so we can work in a place with any facilities connected to the tool. Also, the idea is to create a digital twin that provides a real-time model of the energy digesters, and then we can anticipate new solutions we can found in the facility. Also, we need to anticipate drawbacks and problems we have in the reactor we are not expected. So machine learning is included in this tool just to try the tool makes good the data obtaining from the digester and modify the addition of cautious traits then to face any drawback we can find it. And also, determination of associated cost is needed just to manage properly the facilities. We need to know cost, not only the incomes from the use of energy, also the cost of selling things like high valuable cautious traits. In this cost is also included the environmental cost, therefore greenhouse gas emissions avoided for the use of green energy instead of energy from produced from fossil fuels. Well, this slide is a big chaos probably, but I have to show more or less the things we're working in the project. First, we have to improve or upgrade the existing tool, and then we have to validate this tool with real conditions. For this, we are working first in the pilot plant. I don't know if you can see my pointer, but this is our pilot plant. This is during this disabled. These digesters are inside of this box. And in this facility, we will test the coordination of food waste and pig manure we're using the tool. Also, we are taking data to validate all the models that include in the tool. Then, when the model is validated, we are going to do the replication at real scale in both facilities in Valencia of Global Omnium, in the waste treatment plant of Quarenacher, as here in down part of the slide, and also in Coimbra facilities from Aguas del Centro Litoral. In our facilities, we are working with food waste. That is the current concentrate that we are working with. And in Coimbra facilities, we are going to work with pig manure. That is also the waste they are treating currently. How works the tool? Well, more or less, this is the main scheme of the tool. We have 3 incomes, that is biogas needs, sludge to be treated, and also cautious traits to be treated in the digester. Biogas needs are decided from the operator of the waste treatment plant. The idea is to include every 15 minutes the needs of energy you will have during the day. This is important in some facilities, like in Valencia, our facility in Valencia, because we have thermal drying of sludge when this technology, when it started, have a big demand of energy in the first moment, but after the 1 hour of starting, then the demand goes down and is a plateau. So to have clear these peaks of demand and also values of demand are very important for technology, because the idea is to have or to satisfy these demands in peaks and also in valleys without burning or flaring biogas or have an income from external gas. Then also we have sludge to be treated. This is mandatory for us. The idea of to have a digester in waste treatment plant is to treat the sludge. So this is not this is the most important thing. We have to include it inside of the digesters. So this curve is decided also from management of the waste treatment plant, and this is most of the times it's not possible to change this curve. So the calculation is real, or the real calculation is for the concentrate addition to the digester. Then we have the concentrates categorized in the tool, and then and also we have constraints that are the list as the limitations we have in the system. We have both operational limitations and also limitation for the concentration of some or any compounds like heavy metals. And then attending to these constraints, the tool starts to do the calculation to know the quantity of concentrate that have to include to satisfy energy demand and to maintain stable the digestion. Also, as explained before, we have in the tool a digital twin that works offline. So if you want to make some variations and changes in the operation, you can do the calculation before using the digital twin. And also we have economic environmental models just to know how is the impact or the grade of the impact, or economic impact and environmental impact of the use of the tool. This is important for management because economic situation or issues are the numbers that at the end decides the quantity of concentrates and the quality of substrates concentrate you are using to you will use in the digesters, and also environmental issues is important for not only for live program, also for legal legal issues that we are to accomplish. At the end, finally, to conclude the presentation, I'm show a case study that we are it's a real data of one of our facilities. This is not for the application of the tool directly to the facility. Is just using the results we are obtaining from the project. Here you can see the quantity of biogas that is consumed. Here is the gas we are sending to the motor. The motor is for production of energy and also heat. In green, you can see the quantity of gas that is demanded from thermal sludge dryer. And in yellow, you have the gas used for a boiler to warm the digesters. So at the end, you can see that, as I told you, the thermal drying of sludge, it has a big peak of demand during some this is in days, some during some days, because this is the switch on, and this is the switch off of the system, and you have these peaks of demand of energy that are satisfied by the production of biogas, and during the valleys of demand, we have very few flaring of biogas in this situation. The flaring is going down during the operation of the system, just to have in this part close to zero. So this is more or less the things. I think I go very fast and try to fit in the time we have to explain the project, and hope you enjoy the webinar. And if you have any doubt, you have well, you got my contact and also the contact of the company and the partners, and then ask for questions. Thank you very much.
Thank you, Carlos. Thank you very much for your presentation and for telling us about this quite interesting project. And I saw that in the roundtable there will be more questions with the other projects. I want to go ahead and go to the next speaker, Sandra Jorge. She is the Research and Innovation Coordinator in Aguas do Centro, Portugal. It's our other partner in Life Ecodigestion. She's going to tell us a bit about them and what they are doing in the project. Sandra?
Good morning. Thank you, Adrian.
Good morning. Good morning.
Let me. You see my screensaver? Yes?
Yes, yes.
Okay. So we are Águas do Centro Litoral. We is a public limited company under private law and public capital. It's a part of Águas de Portugal Holding. We are in the center of Portugal, near Coimbra, Fátima, and Porto, between these cities, and we serve 30 municipalities. We treat water for distribution, and then we treat wastewater in our facilities. We produce energy and sludge, and we treat water to reuse. So, in this project, Ecodigestion 2.0, the facility that we choose is one of the biggest facilities, is Coimbrão, near in the Lys River, near the White Farming area and the mouth of Lys River. We have activated sludge with phosphorus removal, and we have tertiary treatment with UV disinfection. Is a particular facility because we have domestic effluents, hospital effluents, piggeries effluents, and landfill leachate. Like this is a challenge for us because it's a facility that have mounted particularities. We have anaerobic digestion with 3 digesters for urban effluents, and like Carlos said, we have big effluents. We produce energy, and the challenge, like Carlos just remember, is we need to increase the biogas production. We need to increase the capacity of the co-digestion, and we need to increase the concentration of methane. In our accredited laboratory, we monitoring the effluents, the sludge, the digestion process, and the pig manure. And one of the particularities of this project that we need to transport the pig manure to Valencia. We need to is one of the parts of this project because Global Omnia need to adjust the tool, but we need to understand what are the quality of the pig manure. So in Coimbrão wastewater treatment, we have to increase the measurement and the monitoring capacity. The next steps is testing the solution in Coimbrão wastewater treatment plant. For this project, we have a team with all the people of many areas, me, R&D, exploration, maintenance, laboratory, and communication. So for us, it's very important. This project is a challenge because we want to increase the neutrality, carbonity, and the circular economy. So this project is very, very important. It's a challenge that we love it. So thank you, all of you, for your attention.
Thank you, Sandra. Thank you very much for everything. If you have time, Carlos and Sandra, if you want to stay for the roundtable in a few minutes, of course, only if you have time. But next, very brief, we are going to welcome Lola Bordas, as the CMO of Finnova. And she's going to tell us a bit about what she's doing for life. Lola?
Thank you very much, Adrian. Apologies in advance because I have today an unstable connection, but just in case, I'm going to spend only 5 minutes in this short presentation, and just in case to explain what we do from Finnova in the communication area, just in case to share the Life Ecodigestion 2.0 project in this. So, then what we do is we try to go further in our actions, in addition to generating constant context and social media, website, etc. But in that, we would like to explain you, we have, for example, the YouTube channel and also a podcast channel. So you can see what we try to explain what life ecodigestion is to other public objective people in order to try to explain this maybe difficult or technician project to all people. We have done these first things that we have done 2 podcasts, and also we really enjoy it. And just in case, I will say to you a little brief moment about that when we do this. And please go to the podcast channel in order to see it, just in case. I would like to say to you, but in this, I suppose you can see it.
Hola a todas y a todos, bienvenidos al segundo capítulo del podcast Life Ecodigestion 2.0. Hoy nos acompaña Pau Granell, jefe de planta, María José Terrera, jefa de procesos, y Carlos Lafita, técnico de innovación del área de aguas residuales de Global Obreo. Hola, buenas. Bienvenidos a todos.
Buenas.
Life Ecodigestion. Del primer podcast del primer capítulo aprendimos que hay un producto final que es el biogás. Pero no llegamos a explicar, a definir cómo se produce, qué es.
Lola,
¿Qué nos podréis contar
sorry,
sobre
maybe
biogás?
there is no need
Era
to
donde
to
aparece.
listen all the podcast because it's in Spanish. So, and
No, that was this, what Haikam said, just in case
please.
people can go with this, and just in case they can go to the Spotify channel in order to see. Go on with more things we do. For example, is the synergies. We have nowadays been 21 network collaboration projects in our website. It means that we have been these connections in another places, like webinars like this, or one-to-one meetings, or event shows, etc. We also want to all people that are interested in do these synergies with us, we come with us and take this and inform and share all the information in the website. And in that, we have done different such success stories. For example, we are trying to go further to this communication, further, for example, to new objective public, and further to new experiences. As an example, we went to explain the Life Ecodigestion 2.0 to Maria Gabriel, that was the commissioner of the European Commission. It was a really interesting experience. And also we have done things like the Life Ecodigestion Startup Europe Awards. The Startup Europe Awards are a methodology promoted by the European Commission, but implemented by Finnova since 2016. What that means, that we have tried to attract startups providing innovative solutions to the challenges of the ecological tradition, and in fact, what the challenge of life ecodigestion. We did, for example, this attraction of startups, and we have a winner, second place, third place, and a special mention. What it means that we have gone to important place that is spoken about these things. For example, it was Green Cities in Malaga, in Figma, and we attract this kind of startups, and then we do give them the prizes to have been done it. It's a way that another people know what it's life ecodigestion, and also know how the European Commission, European Union finance the innovation. And the last thing, special thing I wanted to share with you is, for example, we have done the same thing or similar thing like Startup Europe Awards, but called Girls for Tech. That it means that we explain this challenge to young people, to young girls people that were doing an initiative called Technovation Girls, that is something international. This Technovation Girls is something to attract girls to the STEM careers. So we explain this to this initiative. Some groups of girls try to do this challenge. In this picture, take attention, we have the girls winners, and also the First Minister of Industry, of Science and Innovation in Spain, called Diana Morant, and also the Jean-Éric Paquet, that is the main General Director of Research in the European Commission. And it was that they give the prize for this challenge that the girls have won. What they have done for this? So they just done an app in order to explain how to connect with the Life Ecosystem project. And just in case, let me to share with you this. It's 1 minute at least, and it's really nice to see how young people are introducing themselves the Life Ecosystem concept and trying to do the solution to this challenge.
It's a reliable, easy and effective way to get to do it.
We don't see it. Laura.
You can be.
I cannot see it.
Don't you?
No, we don't see it.
Just a minute. Now?
No.
Can you see? No.
But I think it's okay. We could share it maybe with everybody later because we don't see it. We see the PowerPoint.
So, okay, that's okay
We
for
said it.
me.
We will
Thank you
share
very
it
much.
with everybody. Thank you. Thank you very much.
Thank you. Bye. See you.
It has been very, very interesting. Initiatives within Life Ecodigestion for communication, disseminate, and the work with the children has been very, very, very interesting. Let's go to the, as we are very a bit late, let's go directly to the round table when we will meet different live projects that we will share they will share the experiences with us. We'll start first with Life Less What from Cecilia Caretti. She's researches at the Department of Civil and Environmental Engineering from the University of Florence. So Cecilia, welcome. Could you share with us your presentation and your project? We want to hear you. We want to know your project.
Can you see it?
Yes,
Okay.
we see it.
From here. So. Okay. So good morning, everybody. As you know, the water resource facilities are a source of both direct and indirect green gas, and the direct emissions originate mostly from the biological processes, and indirect emissions are mainly associated with the energy consumed by the process sections. We can see that according to our survey, that the aeration of the biological tanks in water facilities accounts for about 50 up to 60% of the total energy consumption, and so is a major source of indirect greenhouse emissions. And the optimization of the oxygen transfer is therefore a way to significantly reduce the energy cost and the carbon footprint of the wastewater treatment plants. For this reason, we thought that a proper on-site monitoring of the oxygen transfer efficiency and a proper monitoring of direct and indirect greenhouse gas emissions produced in water facilities is essential for assessing the best aeration process management in order to reduce the energy consumption and the carbon footprint. In this context, our project, which was co-financed by the LIFE project, the innovative wireless tool for reducing energy consumption and greenhouse emission of water resource recovery facilities, had the main objective of designing and implementing an innovative tool which can be used to assess and minimize the contribution to the carbon footprint due to the oxidation processes in water facilities. The principal output of the project are a prototype, which I will show you, the LESDRON, which can be used for monitoring the oxygen transfer efficiency and the emission of greenhouse gases during operation, and the protocol, which can translate the information collected into actions aimed at minimizing the carbon footprint of the plants. We were partners from Italy and from the Netherlands and the Benelux, and we were the coordinator of the project. So the last one, which is the main output, for all the details, you can visit our website and we'll find videos and Lemon's report and so on. So I will be very quick just to focus on some points. The Lestron is an automated and self-moving device, which is able to move in the aeration tanks and capture the off-gas. The off-gas are collected and analyzed to evaluate the airflow rate, the oxygen, the CO2, the methane, and the N2O measurements. According to the off-gas method, the Lestron evaluates the oxygen transfer efficiency, which is based considering the mass balance in the gaseous phase between the oxygen content in the reference gas, the atmospheric air, and the off-gas and the oxygen in the off-gas, which is collected by the wood. So, in conclusion, the main outputs and goals that we obtain with our project is that the Lestron, which was tested during the process and also in the afterlife period, is should be a useful tool for the aeration carbon footprint assessment and for the minimization of the carbon footprint in the water resource recovery facilities. The fact that it is able to move around inside the aerated tanks with all the necessary equipment on board ensure the complete automatic mapping of the tanks. Moreover, the data acquired show to be consistent with the plant process condition and provided in very important insights for the plant managers. The instrument not only highlighted the spatial distribution of the airflow, but also assess the total airflow, which is a data that not always is provided by the plant manager, and while is a data that is fundamental to assess the mass balance also of the greenhouse emission and to assess the real energy expenditure of the plants. The Lestron output values prove to be reliable, repeatable, and accurate. And the outputs make it possible to assess the optimal airflow rate and the oxygen, dissolved oxygen to set in the aeration tanks to ensure the pollutant removals and at the same time the carbon footprint minimization. And we assess this in different climate and process conditions in order to have a a protocol which can give the results in any kind of condition. So monitoring the oxygen transfer efficiency make it possible to also to optimize the methods and the frequency of cleaning or replacing the submerged air diffuser, and to optimize the management of the aeration processes in the plant. Thank you very much.
Thank you, Cecilia. Thank you very much for your presentation. We are going to go fast each project, and then we will make some questions if you agree. So let's go to the next project, and there will be a bit of discussion with some questions after all the projects have presented. Well, we are going to the next one, Life Ultimate. We have the Dr. Issam Sabah. Well, I'm sorry if I didn't pronounce your name properly. She's senior researcher at the Institute of Applied Research, the Galilei Society. So, Dr. Sabat, welcome.
Thank you for inviting me. So, do you see my presentation?
Yes, we see it.
Okay, you see it in a mode of presentation, or it's 2 slides, just to be sure?
It's 2 slides. We see 2 slides.
Two slides. So let me switch this back to one. Okay. So just a minute. I'm sorry. It's here. Okay. And now, how you see it? The same?
Yes, we see 2 slides, but we see the slide, so it's okay.
Okay. So just a minute. Okay. I try to arrange it. I am somehow some mistake here happened to my. Okay, just one moment.
I think we see your slide. We see the second slide in smaller, but we see the slide. So if you want to present as it is, it's okay. We see it.
Okay. So let's start. I don't want to lose the time. So anyway, it's not a live project. It's a Ultimate. It's a Horizon 2020 project.
Sorry.
It's okay. Yeah, and I am the Ultimate is actually industry water utility symbiosis for a smarter water society. And we're talking about a Horizon, as I said, the project of 29 partners with 16.6 million euros funded project that will be ended in October 24 this year. And it aims to create economic value and increase sustainability by introducing so-called symbiotic arrangements between industry and water service provider. We look at the 3 resources that can be recovered within this project: materials, nutrients, variable materials and nutrients, water as main recyclable product, and energy. And as I mentioned, we're talking about 24 pilots, 9 case studies, and I will be focusing on the Karmi El Shafdan pilots here in Israel, North and the Best Center of Israel. And the focus here on energy. We have in this, we call it case study number 6, these 2 pilots, and both are being conducted within the partnership of Mokorod. This is the national company, water national company, with SMEs, Agrobics, Greener Than Green from Greece, and the Gulf Society as the lead partner of this case study. The research center that's located here in Shofra Amer. In the first pilot, we introduced the wastewater, the anaerobic treatment wastewater, and this is special technology to treat domestic wastewater in the entire year. I mean, in the warm as well in the winter time, in the cold time, in order, first of all, to protect the system. This is the motivation behind this application at the beginning was that this system here in Carmiel is a special system that faces a huge illegal discharge of agro-industrial wastewater, and this is the industry part, as in this case study, where agro-industrial, mainly olive mill wastewater and other like slaughterhouse effluents and other agro-industrial effluents with high content of organic material comes to the system and make it terrible, and the system shut down for months every year and face a lot of problems. And this was a try of protecting the system by introducing this anaerobic pre-treatment in the beginning as pre-treatment. At the same time, to produce energy, to produce or to reduce the organic load, this high organic load or high organic shock by anaerobic system, and at the same time producing biogas. And here we're talking about olive mill wastewater. We took the case of olive mill wastewater, which is very problematic in the southern Mediterranean countries. And the technology that we developed is based on applying high rate anaerobic system. But unlike USB system, if you are familiar with USB system, upflow anaerobic sludge blanket, in this case, we developed a mobilization technology where we introduce a matrix of polymeric based system that we can immobilize the biomass, and then we can apply high rate without the fear of wash out of biomass. At the same time, we can also at the same time, we have something similar like MBR system, where we have a high solid retention time, where we can treat low organic load, and this is a patented technology. And also, you can visit some of the publication if you would like. So in our case, we mix olive mill wastewater in the beginning or in the entrance with the agro-industrial wastewater, stimulating the real situation where we in general have something like between 0.5 to 1% in average, but this 0.5%, 0.5% of olive mill wastewater sometimes double the COD concentration increase, because the organic loading rate of olive mill wastewater, organic load is very high, where the AET serves as the preliminary, primary or first stage before we continue treating the wastewater in the system itself. We hope, with the hope of producing between 8 to 15 metric cube per day of biogas, and the target is producing biogas, reducing the energy demand in general of the system, and getting or trying to get toward 25% of energy recovery. First goal was achieved actually, and if we look here, it's about a year, the last year of when we run the system, we can see the inlet and the outlet where we get either, if we look at the wastewater, when we mix it with olive mill wastewater or we don't mix it with olive mill wastewater, we reach outlet of the AET system of our technology about 900 to 1,000 milligram per liter. This is, you can ask the question why we have this high COD. The baseline of the COD of the organic matter of this system is actually high, and then we show here briefly, without getting into more details, that the system could shave these peaks, could shave the fluctuations of the very high shocks or very high load of organic material get in because of the olive mill wastewater or any other agro-industrial wastewater. At the same time, we could also show, we can see here also the production of biogas during the time. And this is a function of the organic loading rate as well as the temperature, because when in the summertime, we can produce more biogas. On the winter time, we get less biogas. And this is, as can be seen here, as a function of temperature. The issue that we produce biogas in the entire time, whether, we get olive meal wastewater in the season time or beyond the season time, because our strategy is to keep or to reserve the olive meal wastewater and controlling the treatment by controlling the percentage that we introduce to the entire system. In addition to this system, also we have another pilot is in the Shavdan. This is the biggest wastewater treatment system here. And here we try to produce, it's not only like a pre-treatment, also to make a full treatment of the system of the wastewater by anaerobic process. And we're talking about a combination of the same technology, the advanced anaerobic treatment system with membrane technology, with membrane. Here, I skipped this slide. We can see here, this system is located here, and we can see the membrane. And briefly, if we look at the results of the lab scale, because meanwhile, we still in the beginning, not in the beginning, but we're still facing some problems, running this system on the site. But we show similar results with very low concentration of COD. And here we can see that the COD can be reduced very, very significantly, even, reaching a quality of secondary wastewater without removal of the nutrients, which is another story. And the concept here is to get two main goals. It's one, doing the same, reducing the organic material by anaerobic system, so saving reducing the energy demand by treating anaerobically the domestic wastewater. At the same time, we have this membrane separated from the anaerobic biomass or main anaerobic biomass. Then we can increase, and this is what we are showing here in the lab, increasing the lifetime of the membrane. And then also this is another reduction in the cost of OPEX in this case. So this is briefly what I want to try to tell you about our case study here in dealing with the energy recovery of treating domestic wastewater combined with agro-industrial wastewater. And these the people are behind. So thank you. My acknowledgements go to all of them, and my thanks goes to you for your attention. Thank you.
Thank you, Dr. Saba. Very, very interesting project, and I think it has a lot of opportunities to collaborate with the other projects here today. We are a bit delayed, so we are going directly to Rafael Casillas. He's a chemical engineering specialist in international cooperation at BioAzul. Who is going to present us the project Boost In. I think it's also an Horizon project. And Rafael.
Hello. Yeah, thank you.
Hi.
Can you hear me and can you see the screen?
We see the screen. Thank
Perfect. Yeah, thank you. I'm gonna put it in presentation mode. Yeah, good. Yeah, indeed, Boosting, it's an Horizon Europe project. Boosting is the acronym for boosting the uptake of innovative solutions in the context of water and circular economy. I think the title is quite self-explanatory of what we aim in this project. The idea behind is that there are plenty of research results funded by the European Union and also by national or regional institutions or by the private sector, ending with very interesting results, but results that are not fully exploited or that needs further upscaling or an appropriate business model to reach the market. So the idea behind this project is to support innovators, researchers to achieve this final uptake of innovative solutions in the water and circular economy. This is a coordination and support action funded in last year call of Horizon Europe. So we are not producing any new knowledge. We are working with existing results. The project, it's 3 years of duration, and we have a consortium of 12 partners, 11 direct beneficiaries and 1 associated partner from UK. And well, here is our consortium. The project is coordinated by BioAzul. We also have Agenso, National Technology University of Athens, Ecophilae, Competence Wasser from Berlin, IL Utilities, ZSI, Bulgarian Water Association, Fresh Thoughts, the KEMA, University of Bologna, and Water Europe. So this is a multidisciplinary consortium, also bringing a lot of project results, more than 50 here are some examples. I see that one of them was presented today. I'm happy to see this presentation on the Ultimate project, where our partners of Water Europe and TU and KWB are also involved, but many other relevant projects in the field of water and circular economy are, let's say, present somehow in our boosting project. And the idea is to extend this network with other projects and try to take a stock of all the results and promote them. How we want to do it? We identified several barriers for this uptake of circular solutions. There are barriers of different nature. There are technological barriers. The technologies maybe are not sufficiently scaled or adapted to end users' need, or maybe not sufficiently known. There are also economic barriers. Sometimes economic of scales are not that competitive for circular solutions compared to linear solutions. There are also social barriers. There is no sufficient perception of benefits in society about circular solutions, knowledge, because these technologies require specific skills, also policy barriers or coordination barriers to support the creation of strategic alliances between institutions. So we're trying to perform in our project activities aligned to address specifically these barriers. From the technology perspective, we will do a scouting of solutions, technologies, approaches in water and circular economy to showcase them, to evaluate them, and try to understand their potential with a specific focus on digital solutions. We also address policy barriers, understanding the context in some target regions, and to provide policy recommendations to overcome policy barriers. We will also work with risk management plans, which is a requirement of the water reuse regulation, and we see that many organizations are somehow struggling to produce such plans. We will address trying to do a transition of people's mindset to understand better benefits and impacts of circular solutions and develop roadmaps and action plans. We will also carry out some training and showcase of existing projects to promote the exchange of knowledge. And finally, we will address market barriers, defining adapted business models for circular results through direct mentoring and matchmaking between the problem owners and the tech providers. With all of this, yeah, we are following what we call a funnel model approach, because we are concerned that there is a huge amount of project results. So we are doing like a sort of cascade, step by step. First identifying the bulk of projects, then with characterization, we will create a database, and for some of the activities and services, we will evaluate and select some projects and results to carry out specific supporting activities. It's worth to remark that as part of the project, we are strengthening the existing Water Europe platform, the marketplace, to showcase water innovations, trying to increase the number of innovators showcased and increase the presence of circular solutions in this platform. And we will work more closely to have like context-specific measures in six regions of opportunity: in Lower Saxony in Germany, in Bretagne and Pays de la Loire in France, Andalusia in Spain, Emilia-Romagna in Italy, Strentroni in Bulgaria, and Peloponnese in Greece. And yeah, I will tell you more details in the roundtable, but I wanted to make it close and to the time.
Thank you, Rafael. Then in a few minutes, we will ask you some questions to give more details. But first of all, let's go to our last speaker today, Matilda Mali from the LIFE project Green Life for Seas. She is a PhD in chemistry and environmental technology at the DICATEC, Department of Civil Environmental Land Building Engineering and Chemistry from the Polytechnic University of Bari. So Dr. Mali, if you want to introduce your project, we will.
Thank you very much. Can you hear me? Yes.
Yep. Yeah. We hear.
Is it so visible the presentation? Yeah.
Yeah, we see the presentation.
Okay, good. Let's start in the presentation mode. Okay. So thank you very much for inviting me. I'm the chemical engineering at Polytechnic University of Bari. That it is a lead coordinator of the Green Life for Seas project. To tell you the truth, it's a little bit is within the circular economy, even a little bit different with the previous project already presented. As in the case of a boosting project, the title is quite self-explanatory because our project, the main focus of our project is to valorize two important marine waste that are sediments, that are results of dredging activity within port area, and mussel shells, that it is another waste category of the aquaculture industry, that it is one of the most important for, at least for the two partners, for two countries that have been involved in this project, Italy and Greece. Which is a challenge is why we focus on these two these two waste. The dredging activities are maintenance activities within port and that produce huge quantities of sediments. More than 200,000 million meter cubes of sediments are produced in Europe every year. In Italy, a little bit less. Let's think that only in Apulia region, that it is a southern part of Italy, there are one port for each 12 kilometers. And these ports produce continuously, yearly, sediments that have some specific characteristics. There are the sink for all pollutants that interest the marine area. So their management is a little bit difficult, even for their nature, so by the morphologic point of view, but even because of a complex legislative framework that considered the dredging sediment as a waste. So something that the owner should be find the solution should be find a landfill, a disposal area. Only recently, the sediments have been considered by the legislation as a resource, so a material that can be used and valorized, and so follow a different pathway with respect to the waste. Another waste that have been catch our attention is the mussel shells. As I told before, there are a lot of there is a huge quantity of shells that have been produced by the aquaculture, horticulture sector, and that need to be also, as in case of the sediments, need to be managed. The landfill solution is not a good solution because due to the inorganic nature, they are not biodegradable. So for that reason, it's necessary to find a solution that up to us is not yet identified. More than 10 tons per day, for example, are dumped in an illegal way, so are dumped in the sea, and so they are together with the sediments a waste that that create really difficult for the managing of port or the areas that deal with them. This is the context analysis from which we started with the Green Life for Seas, that it is a triple helix partnership. It includes research institution and academia, include industry, include also some government authorities that want and are, how can I say, have the same objectives to find solution for valorization of these two sediments. We included also in the partnership two network authority, port authority in Italy and one in Greece. So 4 ports that are fully involved in this project. Obviously, due to the nature, the complex nature of the project, the extended network includes also other institutions that are shortly represented in this slide. The idea to work on the sediment started with multidisciplinary research work that has been led by the special commissioner for the named by the Italian government for the national site of interest that it is Mar Piccolo in Taranto. The area is very peculiar because it's under an industrial pressure, that it is an arsenal navy, a cargo port, shipyard, cemeteries that obviously increase and jeopardize the quality of the sediments and the marine waters. But at the same time, this area is in the same area is located one of the most important mussel shells, one of the most important in Europe mussel shell farming that create also a huge quantity of bivalve shells. Beside this, how can I say, anthropogenic pressure, the area is very peculiar because it preserves and stores very particular species such as seahorses or Pinna nobilis and so on. So catch the interest of a multidisciplinary sector, multidisciplinary research activities. During these activities, we, the Polytechnic group has the task to find the solution for stabilization of the sediments. So their beneficial use. The results of the activities are reported in a very important work in the scientific report journal, and you can have much more information about this research by sharing this document. But let's go now to the idea. We saw that during these research activities that these sediments with these peculiar mechanical properties, if are mixed with some with the powder shells. So the powder that comes from the mixing of shells and with a reduced quantity of cements produce a stabilized mass that can be used for realization of different products. The idea is to dry sediments and to dry also mussel shells, not with a higher temperature usually required for calcium carbonate or limestone that it is used for stabilizing sediments, but only with a powder shell that it is calcinated, that it is dried at only 105 degrees. So reducing the greenhouse gases that are emitted during the cement industry and replacing, obviously, the cement that it is usually used for stabilized mass. I will go quickly through this particular research aspects. What I want to say is that the calcium carbonate that comes from the mussel shells has morphological properties that make it a very good element to substitute totally, or at least partially, we are going to substitute it totally, the cement in the construction industry, because it have some the calcium carbonate that it is usually used of shells has 2 allotropic forms, aragonite, that has a higher specific surface and make it active part in the cementation process. So all these results are included in a pattern that we have used as a first element to construct our project. The project is foreseen thus 3 pillars. First of all, the treatment and characterization of mussel shells. and the production of this shell powder, that it is our bioadditive. The second, it is the engineering process of mixing shells with sediments and with lower quantity of cement. And the third part is the industrialization and of the process, so passing from the laboratory scale to the industrial scale, and thus testing on real case within Port Authority this mixing material from which we will realize different kind of products, such as breakwaters or paving blocks that will be directly installed within the port area. So the idea is to reduce surely the cement, to reduce surely all the gas emissions during the production of shells, because it substitutes the cement that it is usually that require high energy and produce high CO2 emissions, and to reduce also the transport, because all this process will be realized within the port. So we will install within the port the implant, the industrial plant that will realize mixing and the final products, breakwaters, paving blocks, and mass stabilization. 4 ports, as I told before, are included in the project. 2 ports that will install and will test firstly the process after the engineering mixing protocol that will be realized by Polytechnic and by the research entities, and after the optimization, installation of this in other 2 ports, ports of La Spezia and port of Pireo. So more than 405 tons of sediments will be exploited, will be used in this project. More than 120 tons of shells will be used, substituting the same quantity of cements, and more than 450 meter square areas will be installed with these eco paving blocks, as we called, 30 meters of coastal will be refreshed with the breakwaters, and more than 40 tons of stabilized mast will be realized and installed directly within the port areas. In the project, we have foreseen to work mainly with uncontaminated sediments, even if quantity, less quantity, so 75 tons of sediments will be undergo to decontamination process. It's a bioremediation process. The bioremediation plan will be installed also within the port areas, and it is supposed that it can be reduced, the quantity of high hydrocarbons, more than 50%. This is a protocol that one of our partners, the CNR from Pisa, have already consolidated in a previous LIFE project, and here we will contextualize with the properties and the condition of the sediments that are produced by our 4 ports that are involved in the project. Here I summarize a little bit which are the expected results, but what it is very important for our project is that we will contribute to the development and especially updating of the national legislation for the beneficial use of the dredging sediments that up to now are already, how can I say, the optimization of the legislation framework is a continuous process, but there are still something to involve, especially the use of the dredged sediments outside the marine area. This aspect is not yet foreseen in the actual legislation, and therefore we hope that this project can really provide a concrete contribute to the development of new optimization of and valorization of these 2 wastes. Thank you very much.
Okay, thank you very much, Matilda. We are very bad of time, so let's go to the questions to discuss a little bit some of the questions. I will start with you as you are the last speaker. What Would you tell us about what is the prospect of the project? You will continue with the project. Is the prospect that you have with the project?
Yes, yes. The idea is, I think that I have another just to. Okay, so this is the, how can I say, the top forward of our project. Since, as I told at the beginning, so the two industrial plants, so the plants for the production of powder shells and the plants for the mixing of powder shells with sediments are mobile plants, we think to transfer this protocol to other ports. So since in the project there are foreseen network authorities, we think that the idea is to make these protocols usable for all ports that are continuously dredging sediments, and especially all ports that are near the, as in case of Taranto or Bari, that are near to the shellfish farming, so that can realize immediately and can exploit directly the benefits of such kind of protocols during the dredging sediments. To tell you the truth, the idea for the future is that Port Authority up to us knows which are the characterization process, which are the optimum options for managing sediments within the port area, but the idea is to find solution for using sediments outside port area, that it is not still foreseen in the. So with the implementation of this project in other ports that continuously needs to make dredging sediments, we think to give to have a good perspectives for the project.
Okay, thank you very much. Now I want to ask Sandra from Aguas do Centro Litoral. Sandra, maybe you could tell us what are the strategic guidelines for the innovation area of Aguas do Centro Litoral?
Yeah, thank you, Adrian. At this stage, Aguas do Centro Litoral strategic guidelines are focusing on the circular economy and the valorization of waste into products, namely the reuse of treated wastewater. We have several projects are under development to use treated wastewater for hydrogen production and other uses. So energy and carbon neutrality, digitalization, and operational efficiency are other of our guidelines, which include the Ecodigestion project. We participated in projects to research and removal of pharmaceutical compounds and microplastics in treated wastewater. So are our focus in the moment.
Okay, thank you, Sandra. I will go to the first speaker, Cecilia from the Life Less What project. Cecilia, could you explain us for what purposes has the less drone been used? So explain a little bit more about it.
Yes, as I told you, thanks to the less drone measurements that can be done in the tanks and to the protocol application, it is possible to assess the greenhouse emission, which according to the new directive will be very important to assess, not with literature data, but with measurements. And it is also important to evaluate the benefits of different operating conditions and management options of the aeration process in order to minimize both the energy consumption and the greenhouse emission without lowering the contaminant which must be removed. And moreover, we can use the instrument in two different ways. We can use as in point test, so for determining the spatial distribution of all the parameters, so we can move the drone inside the tank and have the spatial distribution of all the parameters that we can measure. And moreover, we can do a stationary test. So we put the drone in a set point, and we can measure all the data for at least 1 week in order to assess the variability of the measurement data, so the off-gas and the oxygen transfer efficiency, according to the difference of the day and the night, according to working days and holiday days, and according to different conditions of the inlet. So I think that these are the main points.
Okay, thank you very much. Now it's with Rafael from the Horizon Boss team. Well, let's ask general questions. For example, how does your project promote collaboration between different sectors and actors? Maybe could you explain how do you work on these aspects?
Okay. Well, first of all, we will try to take stock of all these innovative solutions and results and try to increase the collaboration between innovators. That will be a first point. So how to create strategic alliances between innovators. So we want to create a platform for interaction, and but also we want to be proactive in doing what we call matchmaking. Matchmaking means to match the problem owners with the technology providers, because we acknowledge that circular solutions have more problems, more obstacles than conventional products. So trying to create this link between those key players in the industry, for example, that may benefit from circular solutions, and those having the technology, could create opportunities, investment opportunities, and also opportunities to upscaling, to demonstrate, to prove, and have references for innovators. So yeah, so we want to create this collaboration between innovators and problem owners, and also we want to engage citizens to understand the social barriers, to make, because they will be the final consumers. So we also want to promote this change in mindset, so that there will be in the project also activities for raise awareness and showcase. We will organize visits to hotspots of water and circular economy, taking stock of also of our project. We have many demonstration experimental sites with interesting projects that we can showcase also in the frame of boosting. So there are many opportunities for this networking, and we want to have this, let's say, multi-actor approach, not only focusing on end users, but also citizens, industry. I didn't mention, but also addressing policy barriers is important. So engaging decision makers will be also a target in our project.
Okay, thank you. So, Carlos, I wanted to also to discuss with you similar to Rafael, following what Rafael was saying. I understand also live eco-digestion, it could be a showcase, so it could have the opportunity to be busy, to engage with citizens and stakeholders that want to maybe if there is an opportunity there for engaging with the stakeholders. Carlos?
Well, certainly, eco-digestion could be a project. It's a project that has engaged with citizens, because it's directly a concern of the public service here in Valencia and also in Spain, I think in world Europe, because at the end we are producing green energy for the use in water treatment or in other activities that we can put it in the grid. And so at the end. So in the project, we have several activities that we can, sorry. Yeah, we have some activity that we focus to provide information to the citizens. We have visit here in the pilot plan. This at the end is a showcase to be shown, and also to the facilities, real facilities we are working with.
Okay, thank you. We don't hear it. Yeah, it's okay.
No,
It's okay now.
no. Sorry.
Yes. Now we can hear you, Carlos.
No, you can hear me. So at the end, I saying that we use our pilot plan as showcase for also citizens and also to the people who work in our sector, and also we're open to show all our facilities that we are working in and to show the main results we have achieved in the project.
Okay, I hope that soon we'll have some. Well, we inform everybody if there is a possibility to make some showcase in person. Also, we will have our final event in Brussels in a few months. So we will invite everybody who can attend to come and join us in this showcase. At last, I talking about biogas like ecodigestion. Also wanted to ask Dr. Saba about the biogas productions and the last progresses about and developments about these biogas productions and cost effectiveness. So if maybe you want to mention something that even or discuss maybe with Carlos the possibilities to collaborate.
Yeah. Thank you. Actually, the production of biogas, once again, it's dependent on the temperature and the organic material content, and so this is the main limitation. And if we, in our case, because the system in the north is overloaded, so this is the main limitation. If you have enough organic material, which is not the case in many Western European countries, I mean, wastewater in Western European, but in many Southern Mediterranean countries, this is the case. This is beyond the agro-industrial wastewater. But if you have this problem and agro-industrial wastewater can get in the domestic wastewater, and you can control it as we propose here, which is weird, somehow. Yeah, so the production is good actually, and you are not changing that much because it's in terms of effectiveness, in terms of economic effectiveness, even cost effectiveness, because it could be a retrofit. You can come to a first sedimentation tank and convert it, retrofit to a high rate anaerobic system based on our technology. And even we have some calculation for return of investment. We're talking about something like 3 years of return of investment because of the production of biogas. First thing, we can produce something like increase the entire amount of energy by about 20%, plus we can reduce about 15% the total energy demand. And there is another point that this is important, I didn't mention here, is the sludge production. Once you treat 30 to 40, actually we treat between 30 to 40% of the dissolved organic material anaerobically in the beginning, means that if you continue with aerobic system, this is the case that I showed, that the activated sludge-based system will continue working, you produce something like 15 to 20% less sludge. And this is what makes the technology more, let's say, attractive. This is what we think, and we hope, that very soon we can have something like a demonstration scale system to show this in a larger scale, and hopefully we can diffuse to the market. In terms of TRL, we're talking about 7 now. We already 7, 8, something like that. Yeah, so I hope that I answered your question. But
Yeah, of course. Thank you very much. So I don't know if someone else has something to say. I think there has been very interesting projects today that have been presented, that there could be a lot of collaboration among all of you. Just to finish, I don't know, Carlos, maybe just to mention, as your project has been the second project in a row, like ecodigestion 1, ecodigestion 2, I don't know if you think this possibility is quite interesting for the projects to finish one project, use the results to continue with other project, even it could be a different program, because I maybe, I don't know, you have a live program, but then some of the results, it could become an horizon, or on the other way around. What do you think about this, using the results to prepare another project?
Well, the final goal, I think, of this project is to have a commercial product at the end of the investigation or the research we are doing. So in our case, we started with a minor project. We have to develop from zero a tool to manage vulnerability digestion. This is not easy because it depends on a lot of parameters that we have to take care of. Nowadays we are working in the scale up of this. I don't know if finally we will have a commercial product, and maybe we have to invest more time to have a final product just to commercialize it. So at the end, as this is the idea, maybe to break the task in some projects, just to have a linear work, just to have different parts of the work in linear project. Maybe it's a good idea just to reduce complexity of the project, and reduce also the amount of money you need, also the need of personnel, because at the end we need specialized staff to work in this project, and this a limitation also for achieve big goals at the end of the one project.
Okay, thank you, Carlos, very much. So we are we're finishing the project. If any from the public or some other project wants to intervene or say something before we close the event, I just wanted to say thank you everybody to be here, and I hope we could collaborate in the future, and all the attendees had learned a lot about your projects and the experience that you are showing, and maybe there are more people who wants to apply for EU fundings, and also to find to get the grants for their innovative projects. So thank you all very much. If anyone, I let if anyone has something to say or to add. Okay. If not, it's just to say thank you to everybody. Thank you to be here, and I hope we see you in another of the project. So thank you very much to everybody.
Yeah.
Thank you.
Thank you.
Bye.
Thank you.